So now we're going to talk about different ways of submitting Eiffel events and how that can be done securely in a nice way. So there are two main methods of submitting Eiffel events. You either connect directly to the message bus and publish it yourself, or you use some kind of API like Eiffel Rem Publish that accepts your event and speaks to the message bus on your behalf. And in this talk, we're going to focus on the second case, which is probably the most useful one if you want to send events from within your build pipeline, for example, where you don't already have a connection to the message bus, where that might be impractical, like if you have just a Python script or a Groovy script and you don't, or if it's difficult to introduce additional dependencies to AMQP libraries and such. So signed events, that's, I think, a very underused feature of Eiffel. It's not supported widely at all. I think the only implementation I know of is the .NET SDK. And that's kind of weird because while you could require authentication for publishing events, well, you do that if you publish straight to RabbitMQ, but if you use rem publish, authentication is completely optional. So anyone could really post any kind of event, at least if you don't require authentication at all. And event signing is just public key signing of the event payload with the signature stored within the meta security field of the message. So the recipient could verify against the public key of the sender and make sure that the event was sent by someone that's trusted and that the event hasn't been tampered with. Eiffel Rem Publish does not support meta security in itself, but if you use the producer/message endpoint, you could submit a message that you have signed yourself. I don't think you get any validation of that event if you do that. Obviously, if you use the sort of what I guess is the normal endpoint, was it generate and publish endpoint? Of course, you can't get message signing because rem would be assembling the message or the event on your behalf. So unless you would grant rem publish access to your private key, it wouldn't be able to sign it. So where are we going with this? So there are some pretty good reasons for requiring authentication from clients before you accept an event. We talked about that briefly earlier. Because we probably don't want anyone to publish events. Now, if you want signed events and also authentication for event submission, it means that clients need both a private public key pair for signing the event, but also a username password pair or an API key or some other secret to authenticate to whatever API you have for submitting the event. And secrets are pretty annoying to deal with. Every secret is an extra overhead, and I think we should have as few secrets as possible. And this sort of came to me when I looked into what would be required for some of our teams to start producing signed events, and I realized that they would need to, order a service account, add that as a secret to Jenkins, and also look into private public keys and signing and all that. And I figured that this needs to be a better way of doing this. So how about mutual TLS or MTLS? Certificates in TLS, I mean, you're probably well aware of how that's used for how clients use them. I mean, you connect to the server, it announces a certificate that's been signed by some well-known certificate authority that the client trusts, and it's tied to the domain name or host name of the HTTP service. Or, well, it doesn't have to be HTTP, of course. And that makes sure to the client that they're connecting to the one party they think they're connecting to, and there's no middleman attack. going on. And mutual TLS is sort of the other way around, where clients provide a certificate to the server, proving that they are who they are. And the server could then look at who signed their certificate to determine whether they should be trusted. They could also have a list of certificates or public keys that are deemed acceptable, and not necessarily care about who signed that certificate. So I have a bit of a proposal for how to do this for an event submission API. So the client would have cryptography. So if any of you know better, then please correct me. Well, you can use to requests, which basically says you would give it to a certificate authority and ask them to sign your key on your behalf. So you would pass that CSR to, in this example, it's an API of a certificate service that will do this. The certificate service would send the public key. Could be having some kind of network issue here.
Now you're dropping.
Just stop sharing it.
Yeah, I've stopped sharing, but now I am doing via VPN. So I think we're, let's see. Okay, dropped the sharing. Oh yeah, I rejoined. We'll cut this in post-production.
Oui.
Weird. I'll try reconnecting. Otherwise, I have to drop the VPN and we'll see what happens. Yeah. Well, you guess Wi-Fi, yeah. I'll drop the VPN. I don't need it. So see if that helps. Oh, wait, could it be the captive portal? No. Funka Teams för dig eller?
Yeah. There are 5 people in the meeting.
Try to restart Teams. Let's try to your internal.
Yeah. I closed the tab and we'll see if it's.
Continuous delivery first.
Perhaps.
Fail to continuously deliver the message in the abruption.
Yeah, this is very discontinuous.
It's asynchronous.
Okay, I'm back. Literally. Okay, so let's try again. So where was I? Oh yeah. The certificate signing request is sent to the certificate service, which stores the signed certificate or a fingerprint and returns a signed certificate to the client. The client can then reuse the same keys to combine with an event to produce a signed event, and will then use the return signed certificate to post to the event submission service, which shares the certificate database with the certificate service and can use that to authenticate the client and also optionally validate the signature, so it doesn't pass on anything that doesn't where the signature doesn't match. So the benefit I see of this would be that you have one unified trademark way of authenticating clients and events, and so it's easier for really everyone, I think, except that I guess public key cryptography is, might be a bit more work in general than just having a username password, but I think it's more useful in this case. Also, the certificates that are issued could have a certain time to live. So if you want to grant temporary access, this works totally fine. If you want to explicitly revoke access, you can do that by setting up a revocation list of certificates if that's necessary. So I hope this is something, if you think this makes sense, I hope it's something that we can work on, since we have needs, almost immediate needs, I would say, for starting to use signed events.
So one thing in the flow, usually these certificate services are basically, you don't post your signed event back to them. What happens is you get a signed certificate, and then the client who is doing the mutual TLS, he needs to trust the CA, because there is another CA certificate that is issued by certificate service. I can give an example. Let's say client is my Chrome browser or my laptop, and let's say certificate authority is whichever. Let's encrypt, let's say, is a certificate service or DG cert and so on. So Chrome supports, okay, if and let's say GitHub is the one who is sending me, like GitHub.com. So the certificate of GitHub.com, GitHub signed its certificate from Let's Encrypt, and then Chrome says any certificate that is signed by Let's Encrypt CA, I trust it. So that's it. So you don't. So that's why this event submission service is a bit confused.
Right, but you're not talking about mutual TLS. You're talking about the regular TLS. Yeah, and that's a whole separate thing. This service, both of these services would have, of course, also a TLS certificate that the client would trust, and that would be generated by DigiCert or whatever.
Okay.
So this is for the mutual TLS.
For authentication.
Yes, for authenticating the client.
Yeah.
Exactly.
So you would have your own certificate authority. That's
used only for this. Of course, I mean, if you want to have those certificates signed by DigiCert, that might be technically feasible, but no, it's completely unnecessary. So this would be a local CA used only for this. Or, if your organization has well-working public key cryptography and, existing infrastructure for this, go ahead and use it. But I suspect most organizations don't.
That's right, a good question. And most certificates, as far as I know, maybe there are exceptions to it, have a defined time to live.
Yeah.
So if you have an event being created and signed with a certificate with a best before date that happened to an immutable object at an event,
But-
with sort of a non-immutable entity like a certificate? How do you sort of renew that when the
As far as I know,
It's because it's a matter of life cycle. And it's,
yeah, I mean, as far as I know, certificates have a lifespan, but normal keys don't. So you're using the key pair to generate the certificate, and that's where your life. So this has a time to live, but these don't. And these are the ones used to create the signed event payload. I should do it like this instead.
okay.
Right,
I mean,
so-
the most concern is actually about the long life cycle of the event, the immutability.
Yes.
And also the fact that you need to be able to sort of decode it and to sort of check it for its entire life cycle.
Yes. Yes.
Disregard of the whatever it is. Of
Yes.
course, you need to have the entity being there, because if it's sort of original certificate and keys are revoked, you don't have any sort of trust anchor point to check it against. And those generated events will become sort of void in the same way.
Yeah.
Unless you figure out a way to have it. It's more so sort of a very long-term perspective. Nothing you would have to be worried about the first 3 months, yes, but after 30 years or whatever you like to keep your events, then maybe that is.
Yeah. So the idea would be that the database here keeping the certificates would be sort of an append-only database. So all the certificates issued, because you can extract the public key from the certificate. So the event submission service, or really, I haven't included it here, but you could certainly add an API that exposes the public keys from this database. So consumers that want to validate the signature of events could ask that service to, giving the public key of this subject, because the subject is included in the meta security. So that way you'll be able to get the correct public key. But those, even though the certificates are void after a year or whatever, you would still retain the public keys for verification for the 30-year period, or whatever you need. So I think we're covered in that front.
You started talking about RemRem and 2 different ways to send events.
Yes.
Where do you see RemRem in this picture? As I hear it, RemRem is not the client to you.
Hopefully not.
But could RemRem be the client here instead?
Sure, it could be. Yeah.
So
Proxy signing.
should we have some kind of recommendation? I mean, today we have a working way to authenticate and authorize towards RemRem.
Yeah.
Internally. So if we would see RemRem as the client here, we would all this would be done by RemRem then. So the end clients, would say, wouldn't need to bother about this.
No, if you want to do it that way, sure.
But then the events will of course be signed by RemRem and not
Yes.
by the client. Is
Yeah.
that a problem? What
I mean, not a technical problem.
You can have a proxy signing, based on what clients you have. RemRem can sort of use the appropriate certificate and sort of do that in a proxy manner, if that will be sort of safe enough or allowed.
Yeah, depending on your. I was thinking that the client retains their access to their private key and not give it away to anyone else, or for that matter, sign all events by like a generic RemRem subject. But that's up to you.
Yeah, I guess RemRem, the concept of RemRem is that RemRem actually generates the event itself.
Yes, exactly.
So then RemRem is the one who creates the events, which should then maybe sign it as well. Then
Yeah, I mean, it has to sign it.
Input to it would come from another source, from the external clients. Etc.
Yeah.
But that input is not signed. Then probably.
No.
It's
No, I mean, it can't be, since RemRem mangles
exactly.
the event. Yeah.
So yeah, I was just, since you started with talking about 2 different ways, I don't really see where RemRem was here. So that's not, yeah.
Any other comments or questions?
Yeah, correct me if I'm wrong, but I feel like this is a bit maybe redundant. You could just sign the event with the signed certificate that you have, right? And then you can verify that the event itself, and that it came from a signed certificate.
You can't. I don't think you can sign it with the certificate. You need the private key.
Well, you have the private key for it.
Yeah.
So you just sign the event, you don't have to do the mutual TLS thing, since event is signed already. We know that it came from an actual good source.
Yeah, almost. But the problem is
Unless you want to protect against resending as well.
exactly. Replay. I mean, it's not a huge threat, but I do want to avoid replay attacks. But that was my original thought. I'm like, hey, why don't we just reuse, just validate when at the point of receiving the event, when does it validate the signature, and we're done. We know who it is. But replays are, yeah, it wouldn't be great to have those.
Yeah, normal TLS just provides the integrity of the packet, not the authenticity by the mutual.
Yeah.
Even though the packet is integrated, but it's also authenticated, like, so it's not a replay.
Yep. All right, so we'll see if we can get someone to work on this in the reasonably near future.
If you use RemRem, could you replace the mutual TLS with the identification method that you have to this RemRem? Would that be sort of a reasonably good enough, or would you still want to add mutual TLS onto that?
I wouldn't be.
If you do it that way.
Yeah, I wouldn't be super happy about that, because it doesn't solve the sort of original problem of you need. Well, okay, if RemRem gets support for signing and you just authenticate towards RemRem, possibly, but I would prefer
Not
this.
that elegant, no, but it's there.
Yeah, it's there, but it would still, if you want to protect against malicious parties, like we talked about before lunch, people who have the right to publish to the bus but aren't allowed to say anything about a particular artifact, for example, we wouldn't protect against that unless RemRem includes way more logic for sort of access control to the events. So that's why I think that's better to have the signing and authentication done on the client side. And in this event submission service would be, not having quite the same responsibilities as RemRem does today. All right.
This is actually the first time against being serious about utilizing those security mechanisms now. So you seem to be quite serious in sort of in your endeavor to go on to do to have a business case, or at least.
Yeah. I try to be serious. We'll see what happens. But this is the intention, at least.
I think it's worthwhile to see, where there's
Yeah.
a sort of reference. Of course, you should be careful about sort of revealing too much of your security measures, but I think this is a great addition to increase the security.
Yeah.